Everyone, I'm Won Lee. I introduced multiple linear regression model when you are considering more than two explanatory variables. Today, I'm going to continue a little more about this model uh, with R square and adjusted R square. What adjusted R square is. It is important. In multiple regression analysis, the subject of hypothesis testing are as follows. First and second, null hypothesis, beta 1, beta 2, beta p, all of them are equal to 0. This hypothesis naturally should be rejected because if this null hypothesis is not rejected, that means all the explanatory variables included in your model are incorrect, useless. Okay? All of them are useless. So in that kind of case, rarely happen. And another thing, you don't worry about beta 0 because beta 0 is what? The value of y when all explanatory variable values are 0. So it is meaningless. Beta 0 is meaningless, but we need beta 0 for prediction. Okay, let me explain a little more about that later, I think. Second, each null hypothesis, there are p many, beta 1 equal to 0, beta 2 equal to 0, beta p equal to 0. So p many null hypothesis testing is possible. Each hypothesis is for test whether each explanatory variable is significant or not, useful or useless. This case is analogous to the hypothesis testing performed in simple linear regression model. Specifically, it checks whether the i's explanatory variable xi can be included or not in the model, but it is not all of them. So for reference, you need to see the result of this kind of hypothesis testing, but we have variable selection method. So we need to know variable selection method. Let us illustrate with an example. We aim to determine whether the real estate commercial property price Y in certain region is influenced by the land price, building price x2, area of commercial property. This one is the size of commercial property x3. So the multiple linear regression model will be y equal beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon. This is your model. Of course, the assumption for epsilon is follows normal distribution with mean 0, constant sigma square. The result obtained from the sample of 20 samples, 20 commercial properties are shown in the table. This one is the value of y 20, value of x1 20, x2 20, x3 20. Sample 1, sample 2, sample 3 up to sample 20, right? So the calculation result from computer are y hat equal 1470.3 plus 0.8145 x1, 8204 x2, 13.5286 x3, estimated value of parameters. These values are p-value for each hypothesis. For beta 1 equal to 0, the p-value is 0.131, something like that. Okay, understand that? Okay. I use the result of a computer program. Here is intercept 1470.27. Okay, x1 beta 1 hat 0.8145, beta 2 hat 8204, 13.5286, and they are p values here 0.80, 0.131, 0.1001, 0.057. You see the result. This estimated equation from the result of computer work. All right. According to this result, the random price x1 is non-significant because the p-value 0.131, suggesting that it may not be appropriate to include it in the model. So just kick out x1? No, wait for a while. However, this does not mean that x1 should be unconditionally excluded from the model. We will study variable selection section in the coming section. Okay, so you have to, I think, wait for a while. We need to provide a bit more explanation regarding the estimated regression line, previous one. First, each estimated coefficient represents the change in y when the explanatory variable increases by 1 unit. You understand that. Okay? For example, when x1 increases by 1 unit, y increases 0.8145. 8145. In this case, the values of other explanatory variables are held fixed, constant. So other explanatory variables are constant, then x1 increases by 1 unit, y increases this much. Okay, that is regardless of the values of x2 and x3, a 1 unit increase in x1 results in an increase of y by 0.8145. However, if the coefficient for x1 changes as the values of x2 or x3 changes, this should be addressed through an interaction model. So we will study interaction model. You understand this part? Okay. Let's see the adjusted coefficient of determination. I think you have to know this terminology here. The adjusted coefficient of determination is not necessarily better than the regular, okay, normal coefficient of determination. We have R square. And another one is R square adjusted. So you have to understand the difference between two of them. The coefficient of determination indicates how much the explanatory variables explain y, right? I defined coefficient determination like this. When an additional explanatory variable is added, the coefficient of determination will always increase. That means adjusted R square does not always increase. Okay. However, adjusted coefficient of determination is used to evaluate whether the added explanatory variable is meaningful or not. So adjusted R square can be decreased even though one extra explanatory variable included. The adjusted coefficient of determination is defined as follows, like this. You understand SST equal SSR plus SSE, okay? So what is R square? R square is SSR over SST. That means what? SST minus SSE over SST, right? So 1 minus SSE minus SST is R square. But we adjust them, these sum of squares, with their degrees of freedom, adjusted with the degrees of freedom, like this. But it works. Okay, let's see. Here, R square, 0.897. That means 3 explanatory variables explain 89.7% of variability of Y. Y commercial property price are different. Okay, why these values are different. Variability of y can be explained by 3 explanatory variables. 89.7, yeah, 89.7 R square means, and adjusted R square here, this value is less than R square, but this value is not necessary to explain here. Okay, and I will go through many topics in multiple linear regression model, but there is multi-core linearity problem. This is a serious problem. It happens, sometimes it happens, explanatory variable are correlated seriously. Okay, then it may make some trouble. You cannot explain the result of your model, estimated model in the case. So anyway, it is actually graduate level in statistics department. But anyway, I have a plan to explain about that problem sometime. All right, that's it today. Thank you. Bye.